Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into our first lesson on quadratic functions, which are second degree functions here. We're looking at y equals ax squared plus bx plus c. And we're going to learn how to graph them, and we're going to learn the different parts about them. So our goal basically is this, okay? It's a simple one. It's an intro lesson. Is given the graph of a quadratic function, or given the quadratic function itself, draw and find the axis symmetry. So we got to talk about that. Determine whether the vertex, all right, is a min or a max. All right, be able to find the vertex, be able to determine it's a min or max, draw and label the axis symmetry, discuss what that is all about, and actually graph a quadratic function, a second degree function. So let's go through some basics first, okay? First of all, the graph of a first degree function, first degree polynomial function, which is a linear function, y equals mx plus b, all right, that is a line, as you guys already know. All right, something like this. All right, is a line. It has slope. It may have positive slope, negative slope. It may be horizontal. It may be even vertical. All right, but it is a line. A first degree function where the highest exponent is 1 in respect to the x variable here is called a linear function. All right. Well, we're going to study quadratic functions, which are second degree functions. So second degree functions here, and I'm talking about, look at this right up here, ax squared. You'll notice that the highest exponent is 2. It's called a second degree. So the second degree function here is called a quadratic function. Quadratic function. And we're going to study that today in our first lesson. And it is not a straight line, okay? And it requires at least 5 points, to graph well. And we'll talk about that. We'll pick an appropriate domain for the function. We'll evaluate the function at least 5 different values of x, and we'll get 5 points, and we'll graph the function. And then we'll back it up with either TID4 or some graphing software. All right, the standard form of a quadratic function, standard form, right here, you're looking at standard form right here, is y is equal to a times x squared plus b times x plus c. So the coefficients are a, b, and c, and they determine the look of the parabola. All right, a, b, and c are called real numbers. All right, the real numbers. All right, and the only value that a cannot be is 0, because if a was 0, 0 times x squared would be 0, and you would have bx plus c left over, and that would be pretty much the same as y equals mx plus b. It'd be linear. So a cannot be equal to 0. The graph of the curve, okay, is called a parabola. It kind of looks like parabola, but you pronounce it parabola. Okay, everybody say parabola. Okay, not parabola, but parabola. And that's looking right here. This is the graph of a parabola. And notice that 5 points are represented on it, right? And we'll talk about how to find those 5 points. We'll talk about the line of symmetry or the axis symmetry, which I abbreviate AOS in my notes. We'll talk about the vertex and what it means, whether it's a min or a max, and the whole bit. All right, so let's get right into it here. And let's take our first quadratic function here, y equals x squared minus 4x. This is our first function we're going to be analyzing, and we're going to graph it on the interval from -1 to 5. All right, this is representing the domain. Okay, the values of x are representing the domain. Once you input in the function, you get the y values, that is the range. So the domain, as you guys already know, is a set of x values. The range is a set of y values. All right, so what we're going to do is we're going to take x here, whatever x may be, we're going to square it and then subtract 4 times that value. All right, that's the function that we're going to be working on. So we're going to take x squared minus 4 times whatever x is. All right, we're going to start from -1. We're going to go all the way to 5, so write small. So here we go. We're going to start at -1. Now, in reality, you don't know, because you don't have the experience yet, where to start the domain. That comes from graphing a lot of quadratics. It also is determined by where the vertex is, and I'll show you how to find that in my next lesson. But right now, I'm going to tell you what the domain is, and we'll evaluate the function. We'll get many points, we'll plot them, and we'll analyze the graph. So here we go. We're going to take -1. We're going to square it. Got to give it a hug. Anytime you square a negative number, you got to give it a hug. You got to put parentheses around it, and then you got to subtract 4 times that value. Okay, you got to substitute it in everywhere you see x, here and here. This is whatever x squared is minus 4 times that value. So you got to square the value of x and then multiply by, subtract 4 times that value. All right, well, -1 times -1 is 1. And I see a double negative here. -4 times -1 is +4, so we're going to have 1 plus 4, and that is obviously 5. Okay, and that's my first ordered pair, or my first point on the graph. Okay, so left 1 up 5. So let's plot as we go. Left 1 up 5, it's right here. All right, -1 comma 5 is left 1 up 5. Let's plot that right here. So -1 comma 5. All right, I'm just writing down the ordered pair next to the point. And we're going to evaluate this at all x values from -1 to 5, okay? All integers from -1 to 5. So the next one obviously is 0. So what do we have? So 0 squared minus 4 times 0. Well, 0 squared is 0, minus 0, 4 times 0 is 0. Well, that's just 0. So my next ordered pair on the graph, or my next point on the graph, is the origin. All right, right there, 0, 0. All right, next one at 1. So 1 squared minus 4 times 1. Well, that's 1 minus 4, and that's -3. So 1 comma -3. So right 1, down 3. So right 1 down 3 is down here. So 1 comma -3. And my next ordered pair is at 2. So 2 squared minus 4 times 2. That's 4 minus 8, or -4. And so that's right 2 down 4. So right 2 down 4, where's that? So right 2 down 4 is right about here. If you just count. All right, I'm going to label that 2 comma -4. So the points are in red and the coordinates are in black, okay? Okay. And then moving on, what do we have here? So the domain is from -1 to 5, right? So we've got to continue. So 3 squared minus 4 times 3. Remember, the function is x squared minus 4x. So you got to square x and then subtract 4 times x. So let's go for it. 9 minus 12, well, that's just -3. All right, so right 3, down 3. So right 3, down 3, right here. And let's label that. So 3 comma -3. And then next one, we're going to continue at 4. So we have 4 squared minus 4 times 4. That's be 16 minus 16, or 0. So 4 comma 0. So 4 comma 0 is right here, right? 4 units. And we have 4 comma 0 right here. And notice they're not lining up in a straight line, guys. These parabolas, or these quadratic functions, are not linear, okay? They do not line up on a line. They're curves, okay? And the last one, we have 5 here. So 5, so it's 5 squared minus 4 times 5. So we have 25 minus 20, and that'd be 25 minus 20 is 5. So right 5 up 5. So right 5 up 5, we're right about up here. So let me label that one. So 5 comma 5. So when you draw your function here, obviously it's not linear, so you can't line them up with a ruler and draw a straight line, because it's not linear. So what you do is you curve it, okay? These parabolas happen to be smooth U-shaped curves. They're not exactly U-shaped, but it's the best analogy that I can come up with here. I would suggest you do it in pencil, and you do it very lightly first, because you're probably going to have to erase. Right down here at the bottom here, you have to draw a smooth U-shaped curve. And it continues going up forever, so put arrows. Okay, it continues up forever. Continues upward. Okay. And then, let me just clean this up a little bit here. There we go. Okay, so notice that it passes through all the points, and we have a smooth U-shaped curve. So let's write that down. A smooth U-shaped curve. All right. So it's not linear. Okay, it's a smooth curve, and we call it a parabola. Now, before we do anything else, we're gonna graph this on some software first. So notice that I already have the function x squared minus 4x inputted into my graphing program. I'm going to graph it and show you that it is basically the same. So notice that, let me zoom back out here. There we go. If you travel along the parabola here, okay, notice that I can travel along the parabola. The lowest point is right down here. It's at 2 comma negative 4, and if you look at our parabola here that we did manually here, we got the same thing. The lowest spot here is 2 comma negative 4. And notice that it crosses at 0, 0 and 4, 0. You can verify that on the graph too. Okay, notice that it hits here at the origin, and then it goes back up, and it crosses the x-axis at 4 comma 0. So it has the same x-intercepts at 0, 0 and 4 comma 0 right here. So the graph is the same. So everything I'm saying to you here on paper is actually correct, okay? I just want to make sure that you understand that. So let's go through some different parts of the parabola that you're going to need to understand. Okay, the points where the parabola crosses or intersects the x-axis are called x-intercepts. Okay, x-intercepts, you guys already know that. That is something we discussed in linear functions as well. We have two of them. We have one right here. This is an x-intercept. And we have another one here. We have two x-intercepts. Okay, we have 0, 0 and 4 comma 0. And so they're called x-intercepts. I abbreviate it like this, int for intercept. And they're also called zeros of the function because it's where y equals 0. So notice right here, y is equal to 0 on both of those. The x-axis here has an equation, and it's called y equals 0. Okay, that's the equation of the x-axis. All right, and notice that the y value is 0 there. So we call these zeros as well. Zeros. And there's another fancy name for them. They're called roots. Okay, so we're going to write that down too. So roots. You can think of it as a tree. And the x-axis is the ground. And so underneath the x-axis, below these values, represent the roots of the equation. Okay, or the roots of the tree. If this represents a tree, let's say. I think that's where they got it back in the day. All right, but we're going to call them zeros or roots or x-intercepts. They're synonymous, which means that they are the same thing. And these x-intercepts, looking at the graph, the points, or these x-intercepts, are 0, 0, and 4, 0. They're easily found in this case, okay? It's where the equation, or the graph, crosses or intersects the x-axis at the origin, 0, 0, and at 4 comma 0. Pretty straightforward. Now, if you take a vertical line, let's see if I can do this using technology here. Take this vertical line here. Let's take a vertical line, and I grab this here. No, it's not going to work. Hang on. All right. Let's see if I can do this here. And let me select this vertical line, and you sweep it across. There we go. And if you sweep it across the parabola here, there is a place where this vertical line divides the parabola into two equal parts, okay, two equal halves. And if you notice, if you sweep it from left to right here, the vertical line passing right through the vertex here at 2 comma negative 4, you'll notice that the left half is symmetrical to the right half, okay? Symmetrical, meaning they're two equal halves. Well, this line right here, which we're going to call either the line of symmetry or the axis of symmetry, and we're going to draw it as a dotted line because it's not really part of the graph. It's just an imaginary line separating or dividing the parabola into two equal parts. It's called the line of symmetry or the axis of symmetry. So let's draw it as a dotted line first. Okay, right here. It's called the axis of symmetry. Okay, I abbreviate that AOS in my notes so I can make reference to it real easily here. This axis of symmetry here divides or is a vertical line passing through the vertex, or which is also called a turning point, by the way, of the parabola. It represents the line of symmetry. So let's write the line of symmetry down. Line of symmetry of the parabola. Geometrically, it divides, okay, the parabola into equal halves. Okay, so what do I mean? I mean that the left half of the parabola is symmetrical to the right half. Okay, you can see the symmetry if I just do a little shading here. Let's see here. Okay, here's the right half of the parabola, and I'm not talking about the interior of the parabola, but I'm just talking about the right half here. That's symmetrical to the left half, which means that we can reflect points about this line of symmetry and find additional points. So for example, this 0.55 right here, notice that it's 3 units from the line. Well, I can reflect it over here and go 3 units on the other side and get what's called the point of reflection. Right here, 4, 0 is 2 units from the line of symmetry, so its point of reflection should also be 2 units on the left-hand side. So I could reflect that and get another point. And then down here, this is only 1 unit. I can reflect it to get the point of reflection on the other side. These are called points of reflection of the parabola. So if I know a point to the right of the line of symmetry, I can automatically get a point to the left, or vice versa. These are points of reflection. Points of reflection. Okay, and all I need to do is just count the distance from the axis of symmetry, and I can get additional points. So once I plot the vertex and I get points to the right, I can reflect them to get points on the left, and then I can draw the parabola pretty darn easily. Okay. All right, now the vertex of the parabola, in this case, this is the vertex, is either the lowest point or the highest point. In this case, this is the lowest point, so we call it a minimum. All right, so the vertex here represents a minimum. All right, vertex is 2, -4. And the axis symmetry right here, it's a vertical line passing through 2 on the x-axis. So I abbreviate that AOS, by the way, is x equals 2, all right, because any vertical line passing through 2 on the x-axis has an equation x equals 2. Now, if you don't believe me, then let me go back to my graphing program and show you. Okay, not that. Oh, here we go. All right, so let's graph x equals 2, and I'll show you that it actually divides the parabola into 2 equal parts. So in purple is going to be the parabola itself, or the quadratic function, and in red is going to be the axis symmetry, or the line of symmetry. So let's graph both together, and you'll notice that it goes right through the vertex. Let me switch functions here. It goes right through the vertex at 2, -4, and it divides the parabola in 2 equal parts, or 2 halves. And so notice that one point, a point on the right, is the same distance to the right as the point of reflection off to the left. So 4, 0 is 2 units away from the line of symmetry, and so is the other x-intercept. It's also 2 units away. Okay. So any we understand that the line of symmetry, or the axis symmetry, divides the parabola into 2 equal parts. We use it to reflect points from the right to the left, or the left to the right. We understand that wherever the parabola intersects the x-axis is called or they're called X-intercepts, and they're easy to locate if they intercept directly on one of the grid lines. If not, you have to approximate. And if the parabola opens up, then it has a low point called a minimum. So in this case, the vertex here represents either a min or a max. In this example, it represents a minimum or low point. So we're going to write down minimum, okay, and understand that means low point. Okay, so think of it as like a valley. Okay, this kind of looks like a valley, and valleys have low points. All right, if it opens downward, well, guess what? It kind of looks like a mountain or a hill. Guess what? They have high points called maximums. So it changes depending on the parabola. Okay, now let's get used to just identifying the axis of symmetry right here, and let's get used to plotting and labeling the vertex. Okay, and then let's also state whether the vertex is a minimum or a maximum? Okay, we have to determine that. Does it look like a valley or does it look like a mountain? Okay, so on the first one here, I can see that the parabola opens up and the lowest point is right here. And it's right there, and it's left 2, up 1. So that vertex is -2, comma 1. There's your vertex. All right, and it's a low point or a minimum. Okay, it's a low point. All right, the line of symmetry or the axis of symmetry goes right through the vertex every single time. And in this case, because it intersects at -2, right here, the axis of symmetry is x equals -2. We'll abbreviate that AOS, okay? AOS in general. And what we want to do is just identify the min or max, identify the vertex, label it, draw the line of symmetry, or the axis of symmetry always runs right through the vertex, runs through the vertex. And then determine if it's a low or high point. If it's a low point, you call it a minimum. If it's a high point, you call it a max. Okay? So on this one here, on graph 2 right here, here's the lowest point, and it's at -1, 0. It represents a minimum. There's your vertex. We'll call that V for vertex. And the axis symmetry runs right through it. So it's right here. All right, and it goes through -1, so the axis symmetry is x equals -1. It's that simple. On this one here, the parabola opens up, so it looks like a valley, it could be represented like a valley, and its low point is right here at 2, 1. So 2, 1, we'll call that V for vertex, and it's a low point or minimum. And the line of symmetry or the axis of symmetry runs right through it. So the axis of symmetry here in this case is x equals 2 because it passes through 2 on the x-axis. All right. Now this next graph here opens down, and because of that it has a high point, and the high point, the vertex here, is at 2, -1. All right, and this represents a max, all right, which can be represented or thought of as a high point. All right, you can't go any higher than that on the parabola, so it represents a maximum or a high point. The axis symmetry runs right through it, right here. There's your axis symmetry, and let me just make it a little bit more clear. There we go. And it goes through 2 on the x-axis, so the axis symmetry is x equals 2. Okay. On this next one here, the vertex is at, let's see here, left 3, up 14. So -3, 14. There's your vertex right here, and it's a high point, so it's a maximum. And the axis symmetry runs right through it. Right there, there's your axis symmetry, and since it goes through -3, the axis symmetry is x equals -3. This parabola here on the last one here opens up, so it has a minimum. And this vertex right here, let me see, it's left 2, down, looks like down 9. So this vertex is left 2, down 9, so -2, -9. And the axis symmetry is right here. And it passes through -2 on the x-axis, so it's x equals -2. So the very first thing we do is we get used to drawing the axis symmetry, which divides the parabola into 2 equal halves. We understand what the equation is, so we can graph it, okay, on a computer software. We also we know how to find the vertex and understand that if the parabola opens up, it has a low point or a minimum. Okay, and if it opens down, it has a high point or a maximum. Okay, I just say high point just so that it kind of makes sense to you, but the correct word is maximum. Okay, high point. There we go. So we're going to use the words min and max. Okay, max if it's a high point, minimum if it's a low point. And that's all there is to it in our first lesson, that is. Okay, and there's a lot more to learn. All right. However, can't do it all in one lesson, so we do it over time. All right, and so now, example 2, I want you to try it. We have a new function here. It's slightly different than our previous one. In our previous one, we had x squared minus 4x. This one is x squared plus 4x, and it's a little bit different. All right, our domain that we're choosing is a little bit different. We're going to start at -5. So we're going to start at -5 here and then go to +1. So -5, -4, -3, and so on. So at this point, I want you to pause the video here and give it a shot. And then when you're ready, you can go for it and check it and see if you're correct. Okay, so pause the video and do a little pause and play. Pause and try it. All right, and then press play. Then play and check, okay? And check your work. All right, so pause the video, go for it, and then check your work when you're ready. Okay, I'm going to assume that you are complete with this example here, and you're just checking your work. So here we go. Let's check your work. Let's substitute a -5 into the function here. We got to square the value, and then we have to add 4 times the value. So we have to substitute in the 2 spots here, okay? So here we go. We're going to take -5. We're going to square it and add 4 times -5. Well, -5 squared is 25. -5 times -5 is 25. And then we're going to add -20, so plus -20. 4 times -5 is -20. 25 plus -20 is 5. So my first point is 5, -5, comma 5. So I'm going to go left 5 up 5. So left 5 up 5 is right here. All right, so that's -5, comma 5. And then I'm going to substitute a -4. So what do we get? So here we go. So -4 squared plus 4 times -4. All right, so this is 16 plus -16. Well, that's 0. So -4, comma 0. All right. I'm just labeling my points as I go. All right, next one, -3. So -3 squared plus 4 times -3. That's 9 plus -12, or -3. So left 3, down 3. So left 3, down 3 is right here. Sorry about that. I'm just going to put my points in red. So left 3, down 3. That's -3, comma -3. And then -2. So -2 squared plus 4 times -2. That's 4 plus -8. That's -4. So left 2, down 4. So left 2, down 4 is here. All right, and then, whoops, -1. So -1 squared plus 4 times -1. That's 1 plus -4, or -3. So left 1, down 3. And notice it's going down, whoops, down, and then back up. Okay, so I can see my vertex right now. Okay, it's -2, -4. Okay, and then next one at 0. So we're going for -5 to 1, right? So from -5 to 1, that's what's called the domain. Okay, so the domain is a set of x values. The range is what you get out of the function, the output. Okay, the set of y values. So what do we get when we substitute in 0? Well, 0 squared plus 4 times 0. 0 squared plus 4 times 0, that's just 0. So back at the origin right here. All right, and then that's 0, comma 0. And then at 1, so what do we get? So what's 1 squared plus 4 times 1? Well, that's 1 plus 4, and that's 5. So write 1 up 5. So write 1 up 5, you're back up here. So I can already see the symmetry going on here. So 1, comma 5. So let's draw the parabola here. So we're going to go, it goes down, and it hits this special point called the vertex, and then it goes back up. That's why the vertex in this case is called a turning point, because it goes from down to up, right? Okay, and the parabola continues upward. Okay, we see a vertex right down here, so this is your vertex, and it's a low point or minimum. So it's a minimum, This is called the vertex. The line of symmetry always goes right through the vertex, so I can see the axis of symmetry right through here. So we'll call that AOS for axis symmetry, and it goes through -2 on the x-axis, so it's x equals -2. Okay, there is my axis symmetry. I can see the symmetry going on. I know that this point right here, 0, 0, can be reflected across the line of symmetry because it's 2 units away. Let me put this in black. So it's 2 units away here, and it's 2 units away here. So -4, 0 is the reflection across the line of symmetry from 0, 0. And you can see right here that this is 3 units away from the axis. So I can reflect it all the way across here, or I can reflect this one down here. So -1, -3, which is my point in the table right here, gets reflected to -3, -3. So this axis symmetry can help us find additional points which we need to draw the parabola correctly. All right. And then let's see here. Let's answer some basic questions here. I see x-intercepts here. So I got an x-intercept at 0, 0. I got another x-intercept right here at -4, 0. So the zeros, or the x-intercepts, are at -4, 0 and at 0, 0. The vertex is right here at -2, -4. The axis symmetry is x equals -2. It's a vertical line passing through -2. So x equals -2. And the vertex represents a minimum, okay, which represents a low point. Now let's compare that now to what we see on the graphing calculator. So this time though, instead of using my graphing program, I'm going to be using the TI-84 because some of you guys are using that. So let's input the function first. So we're going to input, we're going to select y equals 4 to input our equation in what's called the equation editor. We're going to clear it out because previous people use this, right? And we're going to enter a function in here, y equals x squared plus 4x. So x squared, all right, plus 4 times x. So notice that the function here looks identical to what we have over here. And I'm going to hit zoom. Before I hit graph, I hit zoom. I'm going to hit standard, okay, and see what happens. It adjusts the calculator a little bit for me here, and I can see the parabola coming up. And you can see that this parabola here kind of looks like this one here. The question is, does it have the same vertex at -4, -2, excuse me, -2, -4? So let's calculate that. So actually, you know what we're going to do first? Let me go back to the graph here. We're going to hit trace, and we're going to go left, and we're going to go down to the vertex, and we're going to see the low point. Now, you notice that I can't really get to -2, -4. Okay, so what we do is we calculate it. So go second trace, which is to calculate. We know it's a minimum, so select number 3. And then we're going to go left bound. It just means go a little bit to the left of the vertex and select enter. And then go to the right of the vertex. That's called the right bound. And select enter. And then go back to the vertex. Get as close as you can. That's your guess. And then select enter. And guess what? Look at that. -2, -4. We get the same thing. So let's go ahead and get that graph. All right, and let's bring it in. All right, and you can see that it's the same thing, okay? So the vertex here, this is your vertex at -2, -4. And the axis symmetry is right here. The TI-84 can't graph the axis symmetry, but it goes right through the vertex. Oops. Axis of symmetry, there you go, at x equals -2. So it's the same. All right, whether you use your graphical software, like this program here, I'm going to change this to plus just to sort of show you here, show you one more time. And notice that I have to change the axis symmetry here to -2. There we go. You can see that it's the same thing. So let me just go down here. There we go. Notice the vertex at -2, -4. All right, and that axis symmetry divides the parabola into 2 equal halves. So everything I'm saying here in the lesson can be verified on the TI-84. All right, all right. Okay, now what we need to do is get into another lesson because there's a lot more to learn, my friends, okay? So this is Mr. Ainsworth. If you need to re-listen to this again, it's a video, right? So rewind it, listen to it again, do it as many times as you need to get the full lesson. Okay, and I will see you in my next one in section 2 on quadratic functions. Okay, this is Mr. Ainsworth. I'm out of here. Bye-bye.